meg wide channels, you can actually get twice the bandwidth if you could get them to work, but you've only got one set to 40 meg wide channel in the 2.4 gig region. However, if we look at the 5 gig region, you've got a considerably higher number of non-overlapping channels, which I think if you add them up means you can actually get 12 40 meg wide channels in the 5 gig spectrum. You can probably see what I'm hinting at here. 11N 2.4 gig, absolutely diabolically crap. 11N 5 gig, brilliant, good technology. Okay, this might be a bit confusing. It's a bit confusing for me, but you don't really have to understand it. You just have to understand what a general thread of where this is going. What 11N technology can do is it can do various tricks on the way it handles the data. In fact, a lot of different tricks on how it handles the data. And as such, it's very, very hard to actually think of all the different permutations of how it's sending the data. That's the number of streams it's using, what coding rate it's using, what actual protocol it's using for sending the data. If you add up all the different permutations that 11N can do, it actually comes to 77 different ways of transmitting the data. Now, one of the difference it does, for example, is this thing called a guard interval. Now, guard interval is the space used between the packets of data, between the frames of data. Now, typical 11G, 11B uses an 800 nanosecond gap between the frames of data. With 11N, you can actually take that down to 400 nanoseconds, which gives you an 11% improvement on throughput. So obviously that's producing even more complication with the 77 permutations, because you've got all these permutations and different guard intervals for these. Now, as far as support for 11N technology is concerned, the rules are that in order to be called an 11N product, access points must support, it's called an MCS index, or Modulation Coding Scheme Index, must support numbers 0 through to 15. Which, as you can see, if you were to go for a 40 meg wide channel with a 400 nanosecond guard interval, means we can go up to 300 meg backbone speed with going right up to MCS 15. Now, 11N clients, USB devices, PCI cards, whatever, only have to support 0 to 7. Now, that's important because if you've got an 11N access point which supports, for example, right up to MCS 15, giving you 300 meg, but you've only got a client which is supporting up to 150 meg, then don't be expecting to get a 300 meg throughput. You won't. Now, so these are the bare minimums for 11N equipment. I'm sure as the 11N technology gets improved, chipsets get better and better, then hopefully more and more products will start to support a wider range of these coding schemes. Because some of the higher ones, you can see, you can go up here, you've got a 600 meg throughput coding scheme if you go to MCS 31. Right. Some of the tricks that 11N technology can use to increase the efficiency that it sends the data. So the MIMO side is just on the physical aspects of how it's sending the data, how it's splitting it into streams, to improve data throughput, both in terms of reliability and or speed. And the 40 meg channel width is yet again just another way of getting a little bit more performance out of it, or stability and signal strength coming out of it. Now, the other thing that 11N can do is it can play with the way that the data is encoded in the streams. Now, the first thing it can do is it can do this thing called a block acknowledgement. Now, normally when you send a frame of data on 11G or 11B products, for every frame of data that you send from the transmitter, the receiver has to acknowledge back that it's got that frame of data. And the transmitter will not send another frame until it has received that acknowledgement. Now, with 11N technology, they've come up with this thing called a block acknowledgement, which means it allows the 11N transmitter to send multiple frames and for the receiver to send back multiple acknowledgements in a single burst. So that dramatically improves the throughput because you're not waiting before those individual acknowledgements to come back. Now, the downside of that, of course, is that if there was an error halfway through, let's say, the first frame, the receiver's not going to be able to send back or indicate a problem until all the frames have been transmitted. But you know, it's a compromise thing, and if it works well, this produces a considerable improvement in throughput. The other thing we can do is frame aggregation. Now, every frame of data sent via Ethernet, and by Ethernet I mean over a LAN cable or over Wi-Fi or whatever, every frame of data includes sections of data at the top of the frames and the bottom of the frames, which are information pertaining to the frame. So they have, for example, the destination address, protocols in it, what the frame is going to be about, etc., etc. So this is information that's sent in addition to the actual data in the frame. Now, in its extreme, 83% of the actual information sent in a frame is not the data at all. It's this rubbish that's at the top and the bottom of the frames. Now, what 11N technology allows the products to do is to group the frames so they only have a single section of information data at the top and the bottom. So you have basically frames all grouped together of a similar style or a similar destination, etc., etc., and you can take all that information from those multiple frames, make one giant frame which all has the same header on it, so only one header on it. Yet again, this can actually improve the net throughput of data from the 83% overhead that you can see for 11G or 11B products down to 58%. It's still a big chunk of overhead, but obviously it still is an improvement over the 11G. Now, the big problem with 11N is, of course, it needs to be able to still coexist with the old 11G kit. Now, this is a bit of a pain, and it has meant that this is one of the reasons why 11N has taken so long to become a ratified standard. There's been lots of arguments over the way that 11N can coexist or work with the existing 11GB kit. Now, 11N can work in what is called a greenfield mode. Now, greenfield mode is high throughput greenfield mode. High throughput greenfield mode means is 11 equipment is going to work in pure 11N. It doesn't care about 11G. And obviously, it's the most efficient mode that you can have equipment in, but it does mean that it effectively won't talk to any 11G equipment that's on the network. You've got the non-HD, which is the legacy mode, so this is actually a mode enabling it to talk to 11G equipment only, or you've got a mixed mode. Now, the problem with the mixed mode is it has to send preambles out on the data because it doesn't know what the destination is going to be or the capabilities of the destination. Now, this considerably adds to the actual overhead on the data being sent out. If you could get rid of this, so if you could say, so this mixed mode is actually going to be probably slower than if you just said do it as 11G mode, because of all this rubbish that it's got to send on the data packets just in case the destination is 11N or just in case the destination is 11G. The other thing that 11N can do to try and coexist with the legacy equipment is it can use 20 meg wide channels. It's not good to use 20 meg wide channels because obviously that's going to knock out a lot of the data speed and data bandwidth throughput advantages that 11N's got, but it can work at 20 meg. The other thing that 11N can do is it can do channel reserving. So what that means is it can start off as 20 meg, and then it will hunt around and see if there's another 20 meg channel, and it will reserve it. So once it's reserved the channel, then that essentially stops other 11G equipment using it. Of course, what this can mean in the real world is you've got 11N equipment out there which is rapidly grabbing up the whole of your spectrum. And if it's the 2.4 gig, that means a fully working 11N piece of kit can really hammer what's going on with the 11G in the neighborhood. Right, just going to cover a couple of products now.